This is an example of a geophysical survey that was performed at Carlsbad Caverns National Park, looking for possible small air-filled voids in the limestone outside of the actual park area. The National Park Service was planning to trench in a water line that was currently above ground, extending from a well off-site and supplying water to the visitors center. And they were concerned that they might hit some air-filled voids in the limestone during the trenching. So we were contracted to perform a geophysical survey along the route of the proposed water line to make sure that there weren't any small caves or voids near the ground surface that they might encounter during construction. We had a two-part approach. The first was to perform two-dimensional resistivity mapping along the entire length of the proposed water line. We used what's called a roll-along method and then separated all the profiles into individual cross-sections for analysis. And we reviewed that data looking for possible air-filled voids, which in electrical resistivity would show up as off-scale, very high resistance targets. Then once we identified those locations, we went back and performed 3D resistivity surveys centered on those possible caves to further delineate and constrain their size and depth. These are some photos of the site. It was desert environment, not a lot out there other than this water line. This is the resistivity equipment set up and the 2D transects that we performed. We did have to water all of the electrodes because of the high contact resistance due to the dry and arid conditions at the ground surface. We drilled holes in the rock at most locations in order to get the electrodes into the ground and create good contacts. And this is what that looked like very often. These are the locations of the various stationary transects and roll-alongs that we did. These were ultimately divided up into a series of individual cross-sections for analysis. These are some of the results, and what we're looking for here are these red high-resistance targets. These types of features can be indicative of air-filled voids. This is a location where we thought we had a potential void. Here's another example here where we thought that we may have had an air-filled void. These locations were marked in the field, and then we went back and investigated each of them with three-dimensional resistivity analysis. We set up 4 different grids at these various locations, and then ultimately ended up with these types of results where we could really constrain the approximate size and depths of these various possible voids and air-filled caves. Here's another example of some of those results where we have 3 different possible voids. These are all pretty small, about 5 to 8 feet in diameter. Ultimately, we provided the Park Service with the locations of all of these possible and probable voids. We tried to classify them as possible, probable, or highly probable based on their nature, and provided these GPS coordinates for all those locations. So to summarize, the two-dimensional mapping did identify possible voids along the waterline route. We did have some interference at one location from a buried metal pipe. And then the three-dimensional surveys really allowed us to constrain and delineate and classify these types of voids. We did integrate GPS with all of the portions of the survey so that we could go back and provide the National Park Service with accurate locations for their construction. So this was a very successful application of resistivity to map caves using both two-dimensional and three-dimensional analysis.